Permutations of any type will have two types, that is with repetition and without repetition. Remember, when there are n objects in n number of places, we can write it directly as n factorial. So when you change any letter or when you change the order of the letters, obviously it changes. Now all three is together. All three is together means tie them as one unit. Hello my dear students, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram PU College, the Temple of Excellence, Mysore. So in our previous session, we were learning about permutations and combinations. So let us recall what we have learned in our previous session. So we have learnt about the formation of numbers where digits being repeated and digits not being repeated. So you have to be very careful whatever the question is given. So you should be very careful in studying the statements. That is, they'll give you like choose any 3-digit number, 4-digit number, form 5-digit number without digits being repeated. If nothing is given in the question, you should assume it as the digits are repeated. So you should also be very careful while studying the restrictions in the particular places. For example, form a 3-digit number where 0, 1, 2, 3, 4, 5 numbers are given. So we are supposed to form a 3-digit number. So let me consider it as no digit is being repeated. So therefore, we have a restriction here in the hundreds place. Why we have a restriction in the 100 place? Because if I write 0 in my 100 place, it cannot be considered as 3-digit number. So I cannot fill the place value of 100 with 0. So I cannot take 0, but I can take all other 5 numbers. Okay, so therefore I have 5 choices in my hundreds places. Whereas coming to repetition, if we consider the repetition is not there, then we have only other left numbers to fill other places. For example, here we have 5 choices, but 0 can be included in other places. Therefore, I have 5 choices here also. Now 2 numbers are gone, so I have 4 choices. Therefore, my total number of 3-digit numbers will be 5 into 5 into 4, that is 100. Okay, the same question if we do with the repetition, what happens? So the same question I can say here. Okay, so the same question with 3-digit numbers. What happens? I have hundreds place, tens place and units place. Obviously 0 cannot be filled here. So I have 5 choices left. Okay, how many numbers we have? 1, 2, 3, 4, 5, 6. But all the 6 numbers can be filled in this place also, and all the numbers can be filled in this place also. So therefore, my number of ways here is 5 into 6 into 6. That is 5 into 36. 6 5s are 30, 3 5s are 15, 180. So this is what? With repetition, and this is what? Without repetition. So this you must be very careful while framing or forming digits of a particular number. So you should know about the repetition of digits. Repetition occurs or do not occur. Also, you must be very careful in which places the restriction is there. So whenever the restriction is there, you should fill the place of restriction first. Okay, so in this class, the same concept we will be using for alphabets. Okay, so what are the things we will be studying in this session 4 is, that is word building. So we are forming word using different letters. There also we have 2 kinds of permutations, that is with repetition as well as without repetition. Permutations of any type will have 2 types, that is with repetition and without repetition. That may be in arrangement of people, or previously we have done formation of number. Now we are doing for framing words using alphabets. Okay, so let us learn them one by one. Now, world building, letters not repeated. So here I have taken an example when there is no restriction. So restriction is for a particular thing. So case 1, we are studying with restriction, no restriction. World building, letters are not repeated. Find the number of words that can be formed using all the letters of the word monkey. What are the concept you have studied for formation of number? The same thing you will apply here. Okay. We can see here, we have 6 different letters, okay? That is M, O, N, K, E, Y. All are 6 different letters, okay? So 6 different digits, in the same way, 6 different letters, okay? So we have to form a 6 letter word with or without meaning, okay? Do not care about the meaning. We have to form a word, 6 letter words using these letters from the word monkey, M-O-N-K-E-Y, okay? So therefore, we have 6 letters in 6 places. Therefore, my permutation is 6p6, or we can directly write it as 6 factorial. Remember, when there are n objects in n number of places, we can write it directly as n factorial. So therefore, in the same way, here also we have 6 alphabets in 6 places. Therefore, my answer for this question is 6 factorial. Next, I'll move to the second question. Find the number of words that can be formed by using all the letters of the word rainbow. How many of these begin with R and end with W, end with bow, and begin with row? So let me deal it by one. So let me take my first question. Okay. So we have to find the number of words where they begin with R and end with W. How many letters we have in a rainbow? We have 7 letters, okay? 1, 2, 3, 4, 5, 6, 7. They have clearly mentioned you that the letters should start from R and end with W. So these letters will not be in arrangement, okay? We cannot arrange them. They are fixed. So we are not taking this as count. We'll remove them. We will not consider it for arrangement because their places are fixed. So how many letters are remaining now? That is A, I, N, B, O. So these letters can be arranged. Only these letters can be rearranged. In how many ways? See, we have 5 different letters. Okay. So therefore, 5 factorial ways. Okay. So therefore, the answer for this question. Okay. So the number of words which begin with R and end with W is 5 factorial. Okay. Don't consider it as 7 factorial because the place of R and the place of W is fixed. So they are not in arrangement. Only the remaining letters can be arranged. So therefore, A, I, N, B, O can be rearranged. So we have 5 different letters in 5 different places. Therefore, my answer is 5 factorial. Next question. End with bow. So end with bow, simple. We have 7 letters. Okay. The last 3 letters are fixed. You cannot change their order. They are fixed. So you should not take it as in count. So what are the letters remaining here now? So how many letters are left with here? We are left with only rain. So I can arrange rain in any order. Okay, I can arrange rain in any order. So how many letters we have? Only 4 letters. So therefore, what is my total number of arrangement or total number of words here? That is 4 factorial. Why? Because B, O, W are fixed in their places. You should not consider them for arrangement. Only 4 letters can be rearranged. So therefore, the total number of words formed with you end with bow is 4 factorial. Okay. Next, the same question, begin with row. Okay. Again, we are doing the same problem. Rain, bow. Okay. So how many letters we have? 7 different letters in 7 different places. Okay. So it should begin with row. R, O, W. So I cannot take in count R, O, W. So I have left with these letters now. Okay, so this cannot count for arrangements. Okay, so therefore I can arrange only A, I, N, B. So A, I, N, B can be changed in orders and can be arranged. So therefore my total number of words, okay, so therefore my total number of words where the word starts with row or begin with row is also 4 factorial. So this is very simple. Just use simple logic. So you cannot take the words or take the letters which are fixed in the particular place. You can count only the letters which can be used for the arrangements. Okay. So next question. Now, when few letters, vowels, consonants occur together. So in the previous example, for example, what you have done, monkey. Okay, so rainbow. So when you change any letter or when you change the order of the letters, obviously it changes. One more example. So here we are dealing with a few letters or vowels, consonants occur together. Okay, so here given an example called loafer. Okay, here also, what are the vowels in monkey? O and E. They should always occur together. Occur together means they should be placed next to each other. So that is O and E must be tied as one. Okay, must be tied as one. Remember the arrangement of peoples. When two people occur together, when three boys stand together, what we used to do? We used to tie them as one. Also, we used to take the arrangement of themselves also. In the same way, we are doing this. Okay, and the remaining letters. Okay, M, N, K, Y. Okay, so whatever the letters, whoever the person, they want to be together, tied them as one and consider them as one unit and add with the remaining letters or remaining people. So that will become a total unit. Okay, so what happens here for monkey? It is 6 factorial. Also, OE can be arranged in different ways. That is OE or EVO. Because they are not the same letters, they are different letters. When the letters change their places, their order also changes. So therefore, it is 6 factorial into 2 factorial. The same concept we will apply for the loafer also. Here rainbow also you can take A, I, O. Okay, so A, I, O. Suppose you take A, I, O as one unit. You should take them as one unit. Remaining 4 letters as 4 units. So total you will be having 5 letters. So therefore it will be 5 factorial into 3 factorial. Why 3 factorial? Because AIO can be written as IAO, OAI, OIA in different orders. So therefore arrangement between themselves and total arrangement will be considered like using FPC rule, M into N ways. Okay. The same concept apply here. Okay. So now loafer given. Okay, L, A, U, G, H, T, E, R. So what are the vowels here? A, U, E. So we have 3 vowels. They want to be together. So tie them as 1 unit. So this is 1 unit now. What are the remaining letters? L, G, H, T, R. L, G, H, T, R. So that is how many letters? 5 letters. So 1 plus 5, 6 letters we have. Okay. So therefore total permutations. Total permutation for this one is 6 factorial. What about the vowels? Arrangement of vowels. So total arrangement of vowels. Vowels because they can be interchanged. So therefore 3 factorial. So what is my total number of permutation or how many words? So total number of words. Total number of words when all the vowels occur together will be 6 factorial into 3 factorial. Remember this. Whoever you want to be together, tie them as one unit. You consider it as one letter. Okay. So remaining 5 letters, total you will be having 6 letters. So arrangement of 6 different letters is 6 factorial. But inside the unit also, they can change the place. Therefore, the order changes. So therefore, the order or the number of permutation of this must also be counted. So therefore, that will be 3 factorial. So therefore, total number of words will be 6 factorial into 3 factorial. Next question. When vowels, consonants occupy even or odd places. Okay, here I have taken an example. In how many ways can the letters of the word hexagon be arranged so that vowels are always in even places? What are the vowels we have in hexagon? So we have E, A, O and H, X, G, N. Okay, so according to the question, if vowels occupy even places, then certainly consonants will occupy odd places. How many letters we have? 7 different letters. So here, even places. So they should be occupied by vowels. Okay. So how many even places we have? 3 even places and 3 vowels. So therefore, number of arrangement of vowels or permutations or number of ways of arranging vowels is equal to 3 factorial. Why? Because 3 different letters in 3 different places, 3 factorial. Now, this is for odd. So this is odd. So certainly H, X, G, N, all the consonants should be in the odd places. So therefore, number of arrangements of consonants is 4 factorial. Why 4 factorial? Because 4 different letters in 4 different places. So therefore, what happens to the total number of words here? So therefore, my total number of words will be 3 factorial into 4 factorial or 4 factorial into 3 factorial. Okay. So remember, all the vowels should occupy even places. So there are only 3 places, 3 different letters. So 3 factorial, 4 different consonants, 4 different places. So 4 factorial. So therefore, total number of words is 3 factorial into 4 factorial. Next. So in the previous examples, we have learned how the letters can be arranged when the letters are not repeated. But now we'll come across whenever the letter is repeated, what happens to the total number of permutation. For example, I'll give you a word carom. Okay. So if I change the order of C and M, like M, A, R, R, O, C. This is taken as another one. Okay. So we will take it as one more or another order. If I change the place of A and R, what happens? C, R, A, R, O, M. So this can be taken in count. Okay. If I change the place of R, C, A, R, R, O, M. Does anything alters? No. Okay. If you change the place of the same letter, okay, it will not alter anything. Okay. So therefore, these two are considered as one thing. Okay. So therefore, whenever the repetition of the letter is there, we cannot take it in count. So therefore, we have to remove it. So how we will remove it? By the number of times the letter is repeated. For like how, suppose if carom is of different letters, how many letters we have? 1, 2, 3, 4, 5, 6. So what is the total number of permutation? We would have written as 6 factorial in 6 different places. But since R is repeated, how many times? 2 times. So we cannot take it as take in count. So therefore, we should divide it by 2 factorial. So the same thing what the rule says here. Okay, when there are n things, and x things are repeated and y things are repeated, certainly like z also repeated, then the total number of permutation is n factorial by x factorial, y factorial into z factorial. Okay, I'll take one more example. So look here, the word mathematics. So take the example of the word mathematics. So how many letters we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters, okay, in that. So M is repeated 2 times, correct? Next, A is repeated 2 times. T is repeated 2 times. H once. E once. I once, C once, S once. Okay, so therefore, so total number of words for the word mathematics is equal to 11 factorial divided by how many times each letter is repeated. You have to divide by that factorial. Since M is repeated 2 times, it is 2 factorial. A is also repeated 2 times, so divided by 2 factorial. 2 is also repeated, so therefore divided by 2 factorial, or just simply you can write it as 11 factorial by 2 factorial whole cube. In any one of the form you can write. So be careful, okay. So whenever the letter is repeated, whenever certain things are repeated in a word, so you have to divide by how many times the letter is repeated. So this is an example I have considered. So that's what the sentence here says. So this is the formula, total number by how many times each letter is repeated. I hope you understood. We'll take an example now. In how many ways can the letter of the word hopper be arranged? So if you change the place of P and P, nothing will alter. Okay, so we can clearly say P is repeated 2 times here. Okay, so total how many letters you have? How many letters you have in total? 1, 2, 3, 4, 5, 6. So 6 letters you have. So therefore, so total ways or total number of words, that is equal to 6 factorial divided by 2 factorial. Why 2 factorial? Because P is repeated 2 times. Okay. Next question. So my next question is, find the number of permutations of the letters of the word engineering. How many of this? Begin with E, end with E, have all 3's together, begin with Jane, end with grain. All vowels are not together, no vowels are together. Let me solve them one by one. Okay. So let me consider the letter engineering. Okay, you can observe that how many letters we have. Totally we have how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. Out of that, how many letters are repeated? So E is repeated 3 times. Okay. Next, N is repeated 3 times. G is repeated 2 times. I is repeated 2 times. And then R 1 time. So 3 plus 3, 6, 6 plus 2, 8, 8 plus 2 plus 1, 11. So now this is how the word is repeated. So let me find what is the total number of permutation of the letter engineering. So total will be 11 factorial divided by 3 factorial, 3 factorial, 2 factorial, 2 factorial. Since 1 factorial is 1, no need to write. So this is the total number of permutation or total number of arrangements of the word engineering. Now, let me come to the sub question. What is the first question says? The letters must begin with E and end with E. So E fixed and E is fixed. the last and the first place of E is fixed. So we are only left with the 9 letters. What are those letters? So we are left with N, G, I, N, E, R, I, N. So these are the letters we are left with. That is totally we have 9 letters. So therefore here my total will be 9 factorial divided by the letters repeated there also. So here also the letter is repeating. So in these letters E is not repeated but N is repeated. So therefore 3 factorial, G is repeated, therefore 2 factorial, and I is repeated, therefore 2 factorial. So therefore my total number of words or total number of permutation begin with E and end with E will be 9 factorial by 3 factorial into 2 factorial into 2 factorial. Next question. The same thing, have all 3 E's together. All 3 E's together means tie them as one unit. So E, E, E. So you have to take it as one unit. Out of 9 letters, all the 3 E I have taken as one unit. How many letters are remaining now? So we are left with 8 letters. So total how many letters? 9 letters. So therefore what is my total here? My total will be 9 factorial. Okay. So 9 factorial is fine, but out of these 9 letters also, we have a letters which are repeated. Don't consider E because we tied them as one. Except E, see all the letters. So since N is repeated 3 times, G is repeated 2 times, and I is repeated 2 times, the answer will be like this. Ma'am, what about the vowels then? Since the order doesn't matter here because we have the same letters. Suppose if we have a vowels like this, A, I, O. If you tie them as one unit, okay, but the total factorial will be 3 factorial because if the letter is changed, the order is changed. But the letter here is same. So you cannot write into 3 factorial here. So remember, since the letters are same, there will be no arrangement, only one arrangement. So no need to write here into 1. Okay, so into 1. So therefore this is the answer. Next one, begin with gin and end with green. Begin with gin and end with green. So we have, again I'll write here. Okay, so gin and green. So tie them as one unit. Tie them as one unit. Okay. So here, they should begin with gin means all the letters of first 3 places are fixed. So you should not take it as in count. Okay. And end with green means all the 4 places from the last is also fixed. You cannot alter them. So you should not take it in count. So along this, how many letters are remaining? So we are left with only 4 letters. Okay. So therefore, my answer for this question is 4 factorial. Okay. See here, G, I, N. This one you cannot take in count. Here, green means ring you cannot take in count. We are left with E, N, E, E. Okay, only 4 letters are remaining. You can change their order. So therefore 4 different places, 4 letters. But here also you observe in the remaining 4 letters, 3 factorial I will write. Why? Because E is repeated 3 times. Okay, E is repeated 3 times. The total number may be 4 factorial, but since E is repeated 3 times, we will divide it by 3 factorial. So this is the answer for the third question. Next, so this is done. All vowels are not together. What do you mean by all vowels are not together? All vowels are not together, we cannot count, but all vowels are together, we can count. What are the vowels we can take here? We can take E, I, E, E, I. So these ovals, take this as 1 unit. Okay. So ovals are 5. So therefore remaining will be 6. So 6 consonants. So total will be having 7 letters. Okay. So but what about the permutations here? Okay. So now 5 letters. Okay. 5 letters of ovals. So that is arrangement of ovals. Arrangement of ovals. Arrangement of ovals will be 5 factorial divided by how many times E is repeated? 3 times. How many times I is repeated? 2 times. So this is arrangement of ovals. Next is arrangement of all the letters along with consonants and vowels. Arrangement of remaining letters. Remaining letters with vowels as 1 unit. With vowels as 1 unit. What happens? 6 plus 1, 7 factorial. Okay. So what are the letters remaining here? We have E, N, G, N, R, N, G. So these are the letters we are left with. So here, so we have 3 N and 2 G. Okay, so therefore total will be 5 factorial into 3 factorial divided by 2 factorial into 7 factorial divided by 3 factorial into 2 factorial. This is total number of arrangement where all vowels occur together. Okay, see clearly, tie all the vowels as 1 unit. So vowels with other remaining consonants, 6 letters will become 7. Arrangement of vowels can be done in 5 factorial ways. Since E and I are repeated, I have divided it. Similarly, consonants along with vowels is 7 letters. There also the letters are repeated. Okay, here you cannot take E is repeated 3 times because we have considered it as only 1 letter because we tied them up. So therefore, N is repeated thrice and G is repeated twice. So we will divide it. So the total will be multiply of this. Okay, but what is my question? All vowels are not together. Not together means I know my total ways here. Subtract them with all the vowels together. So therefore, my answer for this question will be, so this is my final answer, that is 11 factorial divided by 3 factorial, 3 factorial, 2 factorial, 2 factorial minus 5 factorial by 3 factorial into 2 factorial into 7 factorial by 3 factorial into 2 factorial. So this is my answer. Okay, here vowels occur together. This is vowels do not occur together. Okay, so next. So my next question is no two vowels are together. So what do you mean by no two vowels are together? So that is, what are the vowels we have? E, I, E, E, I. So how many vowels we have? 5. Okay, next. So what are the remaining? We have N 3 times we have, R 1 time, G 2 times. So totally we have 6 consonants. Vowels cannot occur together means we have to place them in between them. So like this. So either from the first we can start or from the last we cannot, or in between the gaps we can fill. Okay. So now we have 1, 2, 3, 4, 5, 6 different consonants. First arrange the consonants. Okay. So therefore arrangement of consonants. Arrangements of consonants will be 6 factorial by 3 factorial into 2 factorial. This is arrangement of consonants. Well, what about the vowels now? Now I have to fill the vowels in between the gaps. But how many options I have? 1, 2, 3, 4, 5, 6, 7. I have 7 different places for 5 letters. Okay, 7 different places for 5 letters. Therefore, arrangements of vowels will be 7P5. Okay, you are selecting only 5 letters into fill for the 7 gaps. So we have 7P5, but there also the letters are repeated. That is E repeated 3 times, I is repeated 2 times. So this is the arrangement of consonants. This is the arrangement of vowels in between consonant. So therefore, my total number of ways will be 7P5 over 3 factorial into 2 factorial into 6 factorial divided by 3 factorial into 2 factorial. So this is the arrangement where no 2 vowels occur together. Next question. In how many ways the letters of the word accountant be arranged? In how many of them vowels are always together? First, let me check how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we have 10 letters totally. Okay. So A is repeated 2 times. C is repeated 2 times. O is repeated once. U is repeated once. N is repeated 2 times. And T is repeated 2 times. So therefore, first question, let me answer for the first question. How many ways they can be arranged? So therefore, total number of ways will be, so here my total number of ways is 10 factorial over 1, 2, 3, 4. So 2 factorial whole to the power 4. If you write 2 factorial into 2 factorial into 2 factorial into 2 factorial, it is nothing but power 4. So this is the arrangement for the word accountant. But my question, sub-question is, how many of them vowels always occur together? So what are the vowels here? I have A, O, U. Tie them as 1 unit. Okay. So remaining letters are 7. So 1 plus 7 will be 8. Okay. So therefore, here, total arrangements will be 8 factorial. But except A, O, U, we have a letters which is being repeated, that is C, N, T. So therefore, 2 factorial, 2 factorial, 2 factorial. What about this? Arrangement of vowels. Arrangement of vowels will be 3 factorial. But here letters are not repeated, so no need to divide anything. So therefore, my total ways for this question is 8 factorial by 2 factorial whole cube into 3 factorial. Since 2 factorial is repeated 3 times, I have taken it as whole cube. So this is my answer for this question. How many ways vowels are always together? Next question. Find the number of words or the permutations of the letters of the word assassination. The vowels are in odd places. Vowels are in even places. The word nation always together. Begin with AS and end with AS. Let me take them first one by one. Okay. First look at the word assassination. Okay. So how many total words we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 letters. Total 13 letters. How many times A is repeated? How many times A is repeated? 2 times. Okay. Next, how many times S is repeated? 4 times. How many times I is repeated? 2 times. How many times N is repeated? 2 times. Next, T 1 time, O 1 time. So 6, 7, 8, 9, 10, 11, 12. So A is repeated 3 times. Okay. So now, so total we have 13 letters, out of which each letter is repeated like this. So therefore my total number of permutations. So this is total will be always how much? So total will be 13 factorial by 3 factorial, 4 factorial, 2 factorial, 2 factorial. This is my total number of permutation with letters repeated for the word assassination. The vowels are in odd places. How many vowels we have here? A is oval, I is oval, O is oval. So how many? 3, 6 vowels we have. So therefore, the total number of permutation here is 13 factorial by 3, 4, 2 factorial. Now let me take the first question. The vowels are in odd places. How many vowels I have? We have A, I, O are vowels. Okay. So therefore 3, 2, 1. So how many? 6 vowels we have here? So we have 6 vowels and 7 consonants. They have asked you to find the vowels are in odd places. Odd places means first we have 13 places. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13. Vowels must be in odd places means all the consonants must be in even places. Correct? 1, 2, 3, 4, 5, 6, 7. So 7 consonants we have. They are filled in even places. How many places we have for the vowels? We have 1, 2, 3, 4, 5, 6, 7. 7 places we have for the vowels. But how many vowels I have? I have only 6 vowels. So therefore, arrangement for vowels. Arrangement of vowels will be 7 places we have. 6 vowels I have. So therefore 7p6 ways. Well, vowels are repeated there. A is repeated thrice and N is repeated twice. So therefore this will be 3 factorial divided by 2 factorial. What about the arrangement of consonants now? So arrangement of consonants. Arrangements of consonants will be. So we have 7 consonants. So therefore 7 factorial repeated. S is repeated 4 times. Next, N is repeated 2 times. Okay. So this is how 7 factorial divided by 4 factorial. So therefore total number of arrangements will be 7 factorial by 4 factorial 2 factorial into 7p6 whole divided by 3 factorial into 2 factorial. Okay. So this is first question. Okay. Next question. So let me take the same question here. So vowels are in even places. So vowels must be in even places. So the total permutation, we know that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 11, 12, 13. So we have 13 places. We have 6 vowels and 7 consonants. We have 6 vowels and 7 consonants. They have asked you to find vowels are in even places. So V. Okay. 1, 2, 3, 4, 5, 6 vowels in 6 places we have. So therefore it is 6 factorial. So vowels. For vowels it is 6 factorial. But there what happened? A is repeated how many times? 3 times. So therefore you should divide it by 3 factorial and I is repeated 2 times. So therefore arrangement of vowels will be 6 factorial by 3 factorial into 2 factorial. When vowels are in even places, so certainly consonants will be in odd places. Okay. So therefore it will be 7 factorial by 4 factorial. Why? Because the S is repeated 4 times and 2 factorials. Why? Because N is repeated 2 times. So therefore my total arrangement here also 6 factorial by 3 factorial into 2 factorial, 7 factorial by 4 factorial into 2 factorial. Okay. So this is the arrangement when vowels are in even places. Next, the word nation is always together. Okay. What is the word we had? We had a word assassination. this is always together. Okay, so what is the question? The word nation always together. So therefore nation is always together. Tie them as one unit. What are the letters we are left with? 1, 2, 3, 4, 5, 6, 7. So we are left with 7 plus 1. Okay, so therefore my total arrangement will be for this. Total arrangement will be 8 factorial. But A is repeated 2 times, S is repeated 4 times. So therefore 2 factorial by 4 factorial. What about the nation? Nation can also be arranged. So therefore how many letters we have? 1, 2, 3, 4, 5, 6. 6 letters we have. So therefore arrangements here for this is 6 factorial divided by. So there also the letter is repeated. N is repeated 2 times. So therefore 2 factorial. So therefore my total number of arrangements for this question is 8 factorial by 2 factorial, 4 factorial into 6 factorial by 2 factorial. Okay, so let us look at the last question. Begin with AS and end with AS. Okay, so next question, begin with AS and end with AS. So that means the first and last placed are fixed. You cannot alter them. So I have the word assassination. So 1 AS, I will strike it off because they are fixed in the first and end places. I only left with sination. Okay, so there, how many letters we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 letters we have. So therefore, my total number of ways here will be 9 factorial. I cannot take in count this one. So how many times S is repeated there? 2 times. How many times I is repeated? 2 times. How many times N is repeated? 2 times. A, T and O are single. Okay, so this is my answer for the word beginning with S and ending with S. Okay, next question. The last question. Find the number of permutations of the letters of the word unique. How many of these end with Q? Very simple. The last U-N-I-Q-U-E. I cannot take them in count, strike it off because the places of Q, U, E are fixed. The only letters I can arrange is unique. I can rearrange them. So therefore, my answer for this is very simple. 3 factorial. 3 different words, 3 different places, 3 factorial. Next. Begin with U, end with E. Here also the places is fixed. Do not consider U and E. What are the left letters? N, I, Q, U. I can rearrange only them. 4 different letters, 4 different places. I can rearrange them here. So therefore, my answer for this question is 4 factorial. Next question, begin with consonant. They should begin with consonant. What are the consonants we have here? C. So what are the consonants we have? N and Q. How many consonants we have? N and Q. So therefore, unique. Here are 2 choices in the first places. So therefore, this will be 2 factorial. But what about the remaining letters? The remaining letters will be, if I take N in the first place, I have left with 5 other letters. So therefore, there are other 5 letters. In those 5 letters, what? You can see there. So it is 2 factorial. So this is my answer for the question. So begin with consonants. We have 2 choices in the first place. So therefore 2 factorial. So other remaining letters will be 5C2. Why 5C2? Because other 5 letters have 2 consonants. So therefore the answer will be 5 factorial by 2 factorial. So this is the answer for the third question. So this is how we will arrange the letters of the word in different ways. So this is how we will arrange the letters. Now we have learned the arrangement of letters when there is a repetition or when there is no repetition. So be careful in the number of, or in the word of permutations, or in arranging things in permutation, we have two types, that is repetition and no repetition. When there is a repetition in arrangement of peoples or a word or anything, you tie them as verb, consider as one unit. When there is no arrangement, you can clearly say the number of arrangements for n objects in n different places will be n factorial. When you have limited places for large number, then it will be like NPR formula. But you cannot apply NPR formula for all the cases. So we should use these kind of logics in arranging the peoples or formation of digits, or in the framing any words using different letters. So I hope you enjoyed today's class also. We'll meet you in the next session. So keep watching, keep learning, and keep exploring. Thank you.